Hi students, today I am going to explain what are solid crystals. Solids are of two types. We know that they are crystalline solids, amorphous solids. Crystalline solids are the more stable type of solids and amorphous solids are not that much stable type of solids. So crystalline solids, why they are stable? Because they have regular geometry and there will be uniform arrangement of cations and anions in the solid state, and because of this regular arrangement of cations and anions, it will reduce the repulsive interaction between similar ions. So when there are similar ions, the repulsive action will be there, yes, as we know. So it will be reduced because of this regular arrangement, and there will be more attractive interaction between oppositely charged ions. Because of all these characteristics, the crystalline solids are having a more stable structure, and this type of regular arrangement also depends on the size of the cation and anion present in the ionic solid. This size of the ions plays a very important role on the type of lattice it forms. It is necessary for ions to have an opposite charges and to touch each other in order to maintain net attraction. So size of the ions also plays very important role to form a lattice forms. Not only the size, thus these ions should have positive charge, means cations should be surrounded by anions and they should touch each other to have a net attraction between them. So touching each other is also very important. Size is important and they should be oppositely charged. Then we'll see what is space lattice, crystal lattice, etc. Space lattice means a three-dimensional arrangement of points. When we take points, they are arranged in a three-dimensional arrangement that show how the atoms or ions are arranged in a space. So this three-dimensional arrangement of atoms or ions representing the points is called space lattice, and each point here it is called lattice point. And when a space lattice in which the lattice points are replaced by actual atoms or ions, it is called crystal lattice. Here it is an imaginary three-dimensional arrangement of points is called space lattice, and this real atoms or ions which are arranged in the three-dimensional form in space lattice, it is called crystal lattice. Then next is what is unit cell. What is unit cell? So the entire pattern of lattice geometry can be represented by a set of only 4 points. So 4 points, so they will arrange themselves. Joining these 4 points will get a simple smallest repeating unit of crystal lattice, which is called unit cell. This unit cell, it will repeat itself together to form a crystal lattice structure. So the smallest cell of which is having 4 points joined together to form a single cell is called unit cell. It will also have 3 dimensions, x, y, z, and also 3 sides ABC and 3 angles alpha, beta and gamma. So here we can see space lattice. This is lattice point. This is unit cell. Then there are different types of unit cells, as we know. Unit cells are 4 types generally. They are primitive or simple type of unit cells, or body-centered unit cells, face-centered unit cells, end-centered unit cells. We will see what are primitive or simple type of unit cells. In a unit cell which has lattice points only at corners. So only at the corners the unit cell will have lattice points here 1, 2, 3, 4, 5, 6, 7, 8. So, and these are called primitive or simple type of unit cells. These atoms are at the corners of a cube. So a lattice point lying at the corners of the unit cell is shared equally by a unit cell, and therefore 1/8th portion of such unit cell will be there. So we know number of corner atoms is 8, and each corner atom will be shared by all the unit cells, so 1/8. So totally number of atoms in a simple cubic unit cell is equal to 8 into 1/8. So 8 cancel. So 1 will be there in a simple cubic cell. So number of atoms present in a simple cubic cell is 1. Next, see what is body-centered cubic unit cell. In a body-centered cubic unit cell, it has lattice points not only at the corners. So it has at the corners but also at the center of a cube. One point at the center of the cube. So number of items present at the lattice points present at the corners are 8, and contribution is like same at the primitive 8 into 1 by 8 is equal to 1. But in one more atom is present at the center of the cube. It will not be shared by anything in the unit cell. So we will add this. So total number of atoms present is 1 plus 1. So 2. Next, face-centered cubic unit cell. A face-centered cubic unit cell has lattice points not only at the corners but also at the center of each face. So number of corners is 8 as we know, and contribution is 1 by 8. So 8 into 1 by 8, 1. And we know number of atoms at face centers. How many faces are there? As we know, 1, 2, 3, 4, 5, 6. Up, down, 1, 2. Sides 3, 4. Front and back 5, 6. So how many faces are there? 6. So how many atoms? 6. And the contribution of each atom at the face center is half. So contribution of all the faces is 6 into half. That is nothing but 3. So the total number of points present is 1. Contribution at the corners 1 plus this 3. So total are 4. So number of atoms present in a face centered cubic unit cell is nothing but 4. Last is end centered cubic center. So end centered unit cells. A unit cell in which 2 lattice points are present at the center of any two opposite faces. So 2 points will be there extra along with the corners. So it is called end centered cubic unit cell. Okay. Thank you.